Hello, this is Mr. Almack, and we're going to talk today about section 5.3, which is we're going to start looking at graphing rational functions. Alright, so the first thing we're going to do is just look at the graph and see what are the things that we can figure out from the graph without having to look at the equation or really do any math. This is going to be a very visual looking at things and trying to figure out what can we see in the graph. So I have a list here of 6 things that we should be able to find when we look at any given graph of a rational function. We should be able to find the x-intercepts, the y-intercepts, the domain, the range, horizontal asymptotes, or vertical asymptotes. The only one that we might not be able to find on all of our problems will be the range, and that's just because of the way the range is found in some situations. But let's go ahead and look at this problem and see if we can figure out how this works. So first thing we're going to look at x-intercepts. Our x-intercept is where the graph touches the x-axis. And so in this case, our x-intercepts for this problem, the graph touches the x-axis at 0. So our x-intercept on this problem is 0. Alright, next thing, we're going to look at our y-intercept. Our y-intercept is, again, where's the y-axis being hit by our graph. So our y-intercept in this problem, it also crosses at 0. So our y-intercept is at 0. When we move on to the domain is where we're going to look and see what values, what x values are being hit by our graph. And so notice here on this piece of the graph, this is going to go to the left forever. And then it's going to get really close to this vertical dotted red line, but it's not going to cross it. And so it gets really close to this value of 4, but it doesn't cross 4. On the right hand side, this portion of the graph, it's going to also get close to 4. And then it's going to continue and go towards infinity. And so all x values are going to be hit. So we go from the negatives up to positive 4. And then from positive 4 on to infinity. So the only x value that is not being touched is along this red dotted line. And that is an x value of 4. So when we write our domain in this case is going to be the set of x such that x is not equal to 4. Then when we look at our range, we're going to have a similar analysis. We're just going to look at our y values now. So we're going to start near the bottom. So the y values down here, because this part of the graph goes down forever, are going to touch all of our y values. And then it's going to come up and it's going to approach this value here at -2. With this other piece of our rational function, we're going to approach -2 from the top side, and then we're going to increase up to infinity. Therefore, when we're looking at our range, because we're talking about y values, is the set of all y, such that y cannot be -2 in this case. Because every other y value is hit by this graph except for -2. Now when we're looking at our vertical and horizontal asymptotes, these are found on a graph pretty easily by just looking for these red dotted lines. It'll be places where the graph is approaching, but it doesn't cross when we're talking about vertical asymptotes. In this problem, if you look at this horizontal asymptote, the graph does not cross, but it is possible for graphs to move across the horizontal asymptote, because the horizontal asymptote is really just talking about end behavior. So it's only telling us what's happening at the very ends of the graph, all the way to the left and all the way to the right. Therefore, it's possible somewhere in the middle here that the graph crosses the horizontal asymptote, but we'll go over that and how to do that on the next video. Alright, and so when I look at this horizontal asymptote, the horizontal asymptote is going to be an equation. And so on this equation, horizontal line goes through -2. So that means every y value along this line is -2. So it's going to be the equation y equals 2. Notice this is similar to our range. So the horizontal asymptote is often going to be found based on our range, though not always. One of them is not equal, one of them is equal. In a similar way, that's how we're going to find our vertical asymptote. So our vertical asymptote is going to be x equals 4. X equals 4 describes a vertical line going through an x value of 4, which is what we have here. And so whenever we see the domain, if we have values that x cannot equal on a rational function, that can be one of two things. It'll either be a vertical asymptote or possibly a hole in the graph. In this case, it was a vertical asymptote, so notice that the domain and the vertical asymptote match up. On this second example, we're going to be doing the same things. Again, easily you should be able to find your x-intercept. Your x-intercept is you look at the x-axis and you look where does this cross the x-axis. So we have, these are separated by 1, 2, 3, 4, 5 for every 1 unit. So that means each tick mark is 0.2. So this graph is going to cross the x-axis at -1.4. So we're going to have one of the x-intercepts is -1.4. And we'll do the same thing on the right side. We go over here, 2 tick marks past 1, so that's at +1.4. And so we have our x-intercept. For our y-intercept, we're going to look where's the graph cross the y-axis. So in this case, the graph crosses the y-axis at -1. So we're going to have our y-intercept of -1. For our domain, notice this piece here goes from -infinity up to really close to -2 here. Then it goes from -2, falls along this curve up to +2. And then it goes from +2 over to infinity again. And so when we look at this from the domain perspective, our domain, there are only 2 x values that are left out. It's the set of all x such that x is not equal to -2 and +2. When we look at the range, this time notice that our range has a little bit different situation going on. So from the bottom side of this red dotted line, notice the graph approaches this value of -2, and then there's a gap and the graph starts again on the top side. The lowest value on this top side is at -1. So that means there are no y values that exist between -2 and -1. Alright, so if we want to write the range in this case, we're going to write it in interval notation. And so when we start, the lowest this graph goes here is it goes down forever. So we have -infinity up until -2. Negative infinity always has a parentheses, -2. We never actually reach the value of -2, so that's also a parenthesis. Then for the other part of our range, we look where does this graph start, what's the lowest point? So the lowest point here is -1. -1 is actually part of the graph, so we would use a bracket. And then that graph continues increasing into infinity. And so we have our range is this interval here. For our horizontal asymptote is always a y equals equation. So our horizontal asymptote in this case is the equation y equals -2. For your vertical asymptotes are always going to be x equals equations. Notice in this case there are two vertical asymptotes, so we need two equations. We have one here at -2 and at +2, so we have -2 and +2.